Hello and welcome to Focus on Concepts. In today's session, we are going to discuss a very important and a very interesting concept involving light: refractive index. Now, what is refractive index? We'll come to the definition shortly once we have understood this subject. Before anything, let us try and understand what index means. Index is an indicator based on some reference. Health index, poverty index. Well, an index is based on some reference. Let's say a train is supposed to arrive at 11 a.m. That's a scheduled arrival, 11 a.m. So that's the index. Now, if it arrives at 10:30, we talk about the train arriving before time, 30 minutes before time. If a train arrives at 11:30 instead, we say that the train has arrived 30 minutes late. Well, 30 minutes early or 30 minutes late is based on the reference, the index, 11 a.m. That's the scheduled arrival. So, whenever we talk about index, we talk about variance with reference to something standard that we have picked. We'll come to this in some more detail shortly. Let us now understand one setup that we have involving a swimming pool. Well, this swimming pool, which is 10 meters long, has three lanes. Well, swimming pools have lanes, but this swimming pool is a little bizarre, I tell you. This swimming pool has three lanes, all right, but the first lane has water in it, as it is expected to have water. And then the second lane has curd. Yes, you heard me right. It's curd, yogurt. And the third lane has tomato sauce. Yes, tomato sauce. Now, I decide to swim in this swimming pool across all three lanes. I first start with water. And in this case, before anything else, let me tell you that we'll take water as the reference, the standard. We are going to compare our performance or performances in other lanes compared to my swimming performance in water. So this table gets me all the details. So in the first go, I swim 10 meters in water and I clock 10 seconds, which means my speed given by distance by time is 1 meter per second. So my swimming speed in water is 1 meter per second. Let's now see how I perform in curd. When I swim in curd, because curd is thicker, it offers more resistance. Understandably, I took longer to swim this distance of 10 meters. This time I took 40 seconds and my speed was 1 by 4 meter per second. A similar experiment or a try or an attempt got me 1 by 5 meter per second in tomato sauce. So now with these data that we have, let us see if we can process some of these to make some sense out of it. We'll come to it now. We introduce an index called an XYZ index. How do we define this index? This index is my swimming speed in water divided by my swimming speed in a medium. So if I am calculating the XYZ index of a particular medium, the first one in this case is curd. This is the formula I use to calculate it. My swimming speed in water divided by my swimming speed in curd. It comes to 1 divided by 1 by 4 and I get a number 4. Similarly, if I am to define, or if I am to calculate rather, my XYZ index in tomato sauce, it comes to 5. Now, what do these numbers 4 and 5 indicate? 4 here tells me that my swimming speed in water, that's the reference medium, is 4 times my swimming speed in curd. This number 5 tells me that my swimming speed in water, the reference medium, is 5 times my swimming speed in tomato sauce. So what do we interpret? What kind of a trend does this number or do these numbers give me? It tells me that higher this number, slower is my swimming speed in that medium. So if, for example, there was one medium in which the XYZ index came out to 10. What would that number tell me? It would tell me that my swimming speed in water, mind you, water, that's a reference medium, is 10 times my swimming speed in that medium. Interestingly, if I calculate the XYZ index of water, you would see the same numerator and denominator, and therefore this would be 1. And that's why this is the reference medium. Its XYZ index is 1. So in this case, what is the XYZ index of water? It is 1 by 1, and that would be 1. So let us keep this aside for now. We'll come to the other pane of this whiteboard where we try and understand refractive index. The same setup, more or less. Instead of eyes swimming in these lanes, I have light traveling in this media. Now these are optical media. What does optical medium mean? Optical medium is that medium which allows light to travel in it. Water, diamond, glass, these are optical media. Wood, plastic, steel, these are not optical media because they wouldn't allow light to pass through them. So we are only talking about optical media here. Now in this case, whereas water was our reference medium here, vacuum is our reference medium in this case. And we do a similar study for glass and diamond. By the same logic that we calculated the XYZ index, here is the refractive index. It's denoted by the letter N. And when I say the refractive index of glass, it is the speed of light in vacuum. Why vacuum? Because it's the reference medium. Look at this. It was water here, it's vacuum here. And in the denominator, I have the speed of light in glass. I had my swimming speed in curd. This time I have my swimming, or instead it's the swimming, it's not a swimming, sorry, it's the speed of light in glass. And this number comes to 1.52. What does this number say? It says that the speed of light in vacuum is 1.52 times the speed of light in glass. And whereas when it comes to the refractive index of diamond, it is 2.42, and this number tells me what? It tells me that the speed of light in vacuum, the reference medium, is 2.42 times the speed of light in diamond. Again, as this number increases, what do we conclude? We conclude that the speed of light in that medium is slower. If the refractive index of a particular optical medium, let's say, was 5, what does that mean? It would mean that the speed of light in vacuum, the reference medium, is 5 times the speed of light in that medium. So with this understanding, we are good to define refractive index. Just before that, what would be the refractive index of vacuum? Here in this case, it would be the reference medium, vacuum, and the denominator would also be the speed of light in vacuum, and that would give me 1, which means the refractive index of vacuum is 1, and that's the reason why it has been considered to be the reference medium. Now, let us try and define refractive index. What is refractive index of a medium? Refractive index is a number that tells me how many times the speed of light in air, or sorry, vacuum. It's not air, it's vacuum. How many times the speed of light in vacuum is greater than the speed of light in that medium. I repeat, refractive index is a number. And why is it a number? It is a ratio, and therefore it has no units. It's a number that tells me how many times the speed of light in vacuum, the reference medium, is greater than the speed of light in that medium. That's refractive index. Thanks for watching.